because so we're recording this because we put this up on our Genesee Valley Chapter YouTube channel. Now, Carl has promised to give us some in-car video as long as he's here on the spot. But we do have videos from driving events, and we have videos of our Zoom talks. And so this was I think the inspiration by Krista Barbagallo in the club. And we had James Clay, who's the president of BIM World. And he gave our first talk, and Charlie, you are our second. So my name's Ian Dickerson. I'm the president of the Genesee Valley chapter, and it's my pleasure to introduce Charlie Greenhaus. And he's the founder of Entropy Racing. And I guess has this been around since 1987? Is that right?
Yep.
We were chatting beforehand. You can see on the screen, you can see the link to his website, which is pretty cool. And more cool than that, just go to YouTube and search EVSR. I was looking at some of the videos before the chat started. It's pretty impressive. So he's going to talk. Now, let me just do a little advertising. Our next talk is going to be April 1st. It's Rob Siegel. And this is going to be the antithesis of Charlie. If Charlie is high tech, Rob is known as the hack mechanic to all of the Roundel readers in the BMW club, and he's known for getting the most out of the least. And so we don't have a title yet, but it will undoubtedly be something cool DIY about resuscitating aging BMWs on a shoestring budget. And he's always very entertaining. And let me do one more. Whoops.
Just a FYI.
What's that?
We're in actually Sacramento, Pennsylvania, not California.
So I am originally from California. So I, of course, only thought of California. I'll fix that. So let's take that off the screen.
Tiny little anecdote. I had a client who crashed a Lotus 7. We ordered $8,000 worth of parts in a coffin-sized box, and some truck driver called me up and said, "I don't see any 2202 East Main Street. All I see are fields." And it turned out that they shipped a box from England to California. Some truck driver was driving around with a 7-foot-long box looking for Pennsylvania.
That's awesome. Okay, well, let me just, for both our audience and anybody who might be popping in later on YouTube, if Charlie's tales of track mastery inspire you, come on out and drive with us. Looks like COVID is on the wane. We might actually we are going to get on track. We're even going to get instruction. So we're going to be at the New York Safety Track in May, which is very cool. Actually, Charlie, you should bring your electric racer there. It's right up your alley. It's kind of like a large Pine View.
We've been to Safety Track 4 times, I think.
Oh, okay.
Our favorite thing is to push the Super Trofeos around the track.
Yeah. Well, I thought the most unique thing about the New York Safety Track was the owner landing in the middle of the day. So it was the most unique black flag situation that I think we've ever had. But anyway, and then we'll be at Watkins Glen in June, August, and October. So with that, let me, for some reason, there we go, cursor disappeared. Let me stop sharing. And now it should be up to Charlie to take it away.
All right.
Wait, go back one.
There we go. First of all, thank you for having us, or me. Thanks to Jen for getting all the technical stuff sorted out, and for Carl for facilitating this. I have a long history in motorsport. It started back in the mid-late 80s. I started as many professionals. James alluded to it at the last one of these. It's a way to feed your drug. And what happened to me was I was running a Saab Sonnet, and started dating somebody who was time trialing while I was racing. So we built a second car and quickly found out how much it cost to campaign 2 cars and started renting it for endurance racing in the late 80s. Grew from there. Very much of our attitude and our program at the shop, it comes from the old adage of to finish first, you must first finish. And we've always taken a very strong view that it was more important to have a reliable, manageable car and program than it was to wring the neck out of every vehicle you ever sat in. We've been to the 24 Hours of Daytona. We've been to Pikes Peak twice. I've, as a professional, I've worked at the 12 Hours of Sebring. We brought 2 cars to the 25 Hours of Thunder Hill, the 24 Hours of Nelson Ledges. I can't even imagine. It's literally dozens of 12-hour races and probably 100 endurance races besides. My involvement with organizations like CCA, NASA, EMRA, IMG, the Audi Club. I've been chief instructor, competition instructor, obviously a participant with many of these organizations. One of the ways I got connected to a lot of the organizations that I am still working with is for over a decade, we ran a flagging communication service. We were one of the first truly professional services. You called us up, you told us how many stations you needed covered. We showed up and did the job. We worked with CCA a lot. We worked with PCA. We piloted NASA Northeast's program, did some work with Mid-Atlantic. That came out of, actually, we showed up at an understaffed event. And for those of you who have been to events where volunteers are required to flag, probably in the mid to late 90s, it was getting very hard to get enough people to show up. And we showed up with our entire Daytona team of 25 people at an event that had 3 flaggers who actually were willing to stand in the rain. And that started that program. I was the general manager that opened Palmer Motorsports Park. And as I said to Ian earlier, we're associated with Alfred College. Our technical director, Andrew Smith, is their chief instructor, and I'm on their advisory board. As I said, I alluded to the Daytona effort. That was our car. And then in a full field that year, there was an 80 car field or a 78 car field. We qualified a modest 56th, and after putting many broken parts back in the car, we finished a respectful 56th. That was an old Trans Am car that we
Charlie,
bought. And
I'm not seeing any pictures here.
Okay, Jen, no pictures.
So
I don't know. Hang on.
Oh yeah, were you showing pictures?
Yep, not much, but we were not properly sharing a screen, so give us a moment.
no.
Sorry.
Thank you, Carl.
There we go. There's
Well,
Carl.
No,
I figured you're probably doing a little preamble before the slideshow, but when you mentioned the
Yep.
Daytona crew, I figured
That's what I thought.
Yeah.
there we go.
how are we now?
How's
That's
that?
beautiful.
Yeah, perfect.
Perfect. Great. Thank you for speaking up.
Absolutely.
All right, that's words. I already said them. That was us at Daytona in 1999. It was a, as with many teams that go to events like this, you learn a lot. We were obviously a low budget team. That was the year that they had a class called American GT. And it was intended to pick up all the old Trans Am cars and the tube frame GT1 cars. We bought the car for $5,000, put $100,000 in it, and a year later sold it for $5,000. That's kind of what you do in racing. interestingly enough, as I scroll through, there's my skinny young self back then. And as I scroll through this list of people, if you follow the cursors, many of these folks were customers of mine. Some of them were friends. This is Bill Giltzow, who we'll talk about a little later. These are people that I've known since the 80s and many of whom I still do business with. As you all know, the longer you stay in the business, the more you see the same people over and over again. Our shop is, as I said, very much focused on driving the cars. We don't have a garage queen here. Everything we have in here is set to drive. If it doesn't go down the road straight, it gets worked on until it does. This is an E-type that we see every couple of years, and it's always for just maintenance items. That's a Mini we built for a client about 3-4 years ago. That was basically a rotisserie restoration. That's an MGTD with a Volvo motor, a B1600 Volvo in it, which every year it comes back for more service to make it a little nicer every year. That's our favorite delivery truck. It's a 60 Morris Minor. As you can see, it's full of tires because if you're going to have a pickup truck, you should use it. That is a recent acquisition from a customer, which is a really, really nice 240 Volvo, which we've been working on. If any of you guys are micro squirt specialists and know a good dyno shop that works with micro squirt, let us know. Because that's our last task on it. We got it dialed in and handling well at stops. It just doesn't quite go well enough. But as you can see from all this stuff, that's a NASA fellow we've known for a long time. He's 6'8" and sits in the back seat. Obviously not a CRX driver for that very reason. But he hauls his crap all the way out from Long Island for us to work on. And as I said, drivers, it's a nice day, a little snow on the ground. It never hurt to take your car out. This shot was taken a couple of years ago. And one of my favorite phrases we've heard for years is junk breeds junk. As soon as you get a Peugeot, 3 more roll into the driveway. You don't know why, you're not sure you wanted them to, but all of a sudden you've got them. In my 35 years of being in cars as a professional, I owned one BMW until about 8 years ago. Now I think I own 4. I sold I've got 4 myself. Down this list, that's a client's 2002 that we just changed to an M42, RZ3, a client's, a 535. That is a 360,000 mile, 2-owner 325E. My stepson had a 325 that he beat to death and we resurrected 100 times. And a CS, which I tried to enjoy for many, 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 many years and never quite fit the car. We sold that recently, and that's where the 928 came in. As I said, shops, testing the metal, the quality of a shop is rarely seen from their successes. It's how they deal with their failures. And this car came to us for the typical rear subframe reinforcement. And when we were 90% of the way done with the job and we're welding underneath, one of our guys caught fire to the car rather spectacularly. About a month and a half later, parts car later, we somehow we lost the finished picture. Oh, nope, it's top left. That's what the car looked like when it was all done. That is not an M, but a very worked track car that I don't believe he runs CCA events very often, but it's been discussed, and one of my other clients is real good friends with him, so I'm sure you'll see that car in the future. That is our chief mechanic, Dale, working on I don't know whether you call it, I guess you'd call it resurrecting. This was a E30 M3 that was tracked. It was caged and tracked and walled at Watkins Glen. The whole left side of it was creamed. There was no, the hood was a rust bucket. And 16, 18 years ago, it got parked under a tarp. Life got in the way. And last year we got a phone call that said, these things are worth money now, aren't they? And I said, just a wee bit. Why? And he says, can we turn it back into a streetcar? And there's really probably one of the largest challenges is trying to take a valuable car like that and make it whole again, put the carpets back together, get it all working, find all the stuff that got thrown out the window when you turned it into a race car. And it came out really well. Right now, we affectionately call it the Rat Rod M3 because we haven't done any of the body work. We've got all the mechanicals and made it reliable. And at some point, he's talking about getting the body work done, but he knows as soon as he does that, his wife is going to make him sell it. So that's probably not going to happen for a while. This E36 has been totaled twice, once with me in the passenger seat. And if you notice the way this striped nose is, that's where the new front of the car is. It got put in the wall in the rain up down at VIR, and then subsequently turned back into a streetcar as a first car for the customer's daughter, who subsequently slammed it into a curb and folded the whole right front of the car underneath itself. And then once again got turned back into a track car and has been campaigned regularly. When I acquired the car as a service customer, it had 210,000 original miles on the motor, transmission, and rear. And it's now up to 260,000. And the only thing we've done on it in terms of the running gear is a head. So while I'm not in love with E36s, they're a little porky for my taste, I have to say it's a tough old car. If you notice that red 2002 earlier in the slides, this is that car about a year and a half, 2 years ago, and it is now an M42 powered car. And it was built basically to recreate the client's college car. And he puts probably about 6,000 to 8,000 miles a year on it. And it's nice to see. It's nice to see them driven. That's what they're meant for. This modern trend of spending $50,000 for a 2002 so you can park it and say you own it, I find a little disturbing. And I do appreciate that clubs like CCA are as much about preserving the heritage as they are about using the vehicles and giving people an opportunity to enjoy them. Broken parts, fixed parts.
Thank you.
This is a car that we just finished, and actually, if for all of you people that are masochistic enough to watch Bring a Trailer, it will be on Bring a Trailer next week, and feel free to buy it. It will pay for a new roof on my shop. And these are two projects that are happening simultaneously. The client with the M42 2002 is building this into a full-out race car and wants to power it with an M42. And this car is a car that I acquired about a year and a half ago. We're in the process of turning that into an EV. As we get further along in this program, we're going to talk more about the EVs and EVSR. This car is being built to demonstrate our drive lines and our packaging for what we use in the race car. It should weigh in at about 2,600 pounds and have about 180 wheel horsepower. So it'll be quick, little on the porky side, but quick. And the unusual thing about it is it won't have a transmission, and it will be mid-motored and rear-wheel drive. So the rear seat comes out, the drive shaft tunnel gets cut away, and the motor gets placed basically where the back seat was, in line with an E36 rear, which will graft some drive shafts together and then drive the rear wheels.
What?
This
Yeah.
is our first generation car.
Kidneys?
Of EVSR. For those of you who are well versed in SCCA racing, you'll notice that the body and chassis look very similar to a Spec Racer
Okay,
Ford,
keep going down.
and that is because it is.
Rolling. Someplace I saw it. It's
I'm
just my
sorry?
kidneys.
Charlie?
I'll live with
Charlie,
it.
can I interrupt? We're
Yes.
starting to get more and more background noise. So if folks, why don't you guys voluntarily mute? And then if you have questions, you can unmute. Thanks. Okay, go ahead, Charlie.
No worries. So one of the things that happened when we got the commission to do our first EV, it was actually, the interest was the client wanted us to build him a Lotus 7. And this is back in 2013. And we looked at the viability, we looked at the packaging, and we said, not so much. It's going to be really hard to make a car that you're going to enjoy with range that will give you what you want. And he very much was a driver. He was a racing client of ours and a performance driver his whole life. So we refocused and decided to use what I already had, which is we've been renting race cars since late 80s, early 90s. And in the mid-late 90s, we started acquiring the soon-to-be obsolete sports Renaults. So I have a fleet of 16, 18 cars, and we looked at it, realized there was good placement for the batteries, the chassis is pretty balanced and well sorted. So we decided to use that as our original mule to do the EV conversion. We cut off all the side structure on it, gutted the center, and then moved the driver forward and made a longitudinal rear wheel drive car with, if you look here, if you follow my cursor, you'll see a coupler directly from the motor to an E36 medium-sized diff, which was both readily available and came in numerous gear ratios, which was important to us because we really weren't sure what we were going to need for ratios. In our first year, we were exceedingly aggressive with both testing and track time. We did over 40 days at the track. We had a dozen dyno runs in less than 2 months. We went from blank sheet of paper in November of 13 to our first competition event in the middle of March in 14. And by the end of 2014, we'd gone to over 20 weekends. We had 4 overall finishes against gas cars. And pictured here is Tim O'Neill, 5-time US Rally champion and 1991 overall winner of the Mount Washington Climb to the Clouds, driving our car. We were fortunate to be able to acquire his services for this, and he did a fantastic job. In his, well, we're going to try a video. Carl said they weren't so great, but let's take a quick look. This is actually me driving on a demonstration run at Mount Washington. Do you guys have audio?
No.
No audio? Hang on a second. There's not a lot of audio. Their cars are pretty quiet. But Jen is working on that right now. One of the interesting things about driving an EV, and there are numerous interesting things, but one of the really interesting things is in wheel-to-wheel competition, it gives you a really significant advantage in that you're able to hear your other competitors where they can't hear you. And what that does for you is when you're next to somebody and coming into a corner, you can hear them lift, you can hear them throttle, you can even hear them brake. And it's really amazing to be able to, without looking in your mirrors, without looking to your side, know that you have a corner. The whole purpose of this video is for that view, by the way. Let's see if I can.
Nice.
There we go. Nope. No, we don't want to do that. Jen, I think I'm having technical difficulties again.
Where are you now? Oh, wow. What did you do?
I double clicked.
Huh.
Where?
Here we go.
Where?
I don't know where. I double clicked on the screen.
Huh.
Mount Washington was very interesting on a lot of levels, though, because it was our first high profile event. Travis Pastrana was there, got second overall, I believe, that year. At the subsequent event, he was first overall. And there's an opportunity.
Sorry, guys.
Yeah, there we go.
No,
No,
no.
okay,
The presentation's falling apart before
okay,
your eyes.
here we
Hang
go.
on. Hang on. Keep talking.
Keep talking. One of the things that was very interesting for Tim is he had never driven a sports racer. He'd never driven a road race car. He'd never driven a car with that much grip, and he'd never driven a center seater. So he was put in a position to, with very little time and very little practice, to just jump out there and go. And
No more videos.
no more videos. Well, we're going to do one more video later, I think. But this is our first practice sheet from that. And if you look very carefully, you'll notice that out of 80 cars in his first, literally his first quarter of a mile driving the car, and then the bottom half of the mountain, which was about 3.5 miles, he was the sixth fastest car out of 80 on his first trip in the car. Ultimately, he was 21st overall. And if we scroll down this sheet, down to 30th position, we will notice, who do we see down there?
Yeah, that's Roy Hopkins in the 2002.
And Roy is somebody who I have yet to meet, but it has come to me by legend from many friends and people who know him. And I'm sure I'm going to meet him soon because we're looking to buy a motor from him for one of those project cars in the shop. But it is interesting to see who shows up at these events. And you know, sometimes it's like old home day. It's like, hey, how you doing? What are you doing here? And, you know, we're trying not to fall off the mountain. This is the top of the mountain with 4 years ago now, with Mike Wilson and myself. Mike was in the better of the two cars. That's my excuse for having him kick my ass all over the place. But this was his first time at the mountain, his first time ever driving a road race car on dirt, because there's still a mile of dirt, and missed Tim's time by about 1/10 of a second, I believe. So Tim is still the reigning electric champion at Mount Washington. And this year we're going back with Mike and our lead driver, Todd Reed, with two pretty well worked cars. And we're very confident we're going to set a real fast time. The following year, we went to Pikes Peak. And as James alluded to at the last presentation, it's quite a mountain. We went with a real all-star team. Rick Knoop, who you may or may not know, but in 1978, in his rookie year, went to Le Mans with Rick Busby and won his class, and they were a top 5 overall finish. And in 1982, we went back and I believe got second in class and a top 5 finish overall. I met him down in North Carolina the year before our first Pikes Peak, and he had just finished 11th overall in a really impressive, about a 700 horsepower Lister special replica that was really neat. But in that first year, we lost one car off the mountain. In practice, we had what I would consider a pretty ugly crash with a pretty good outcome. 200 feet off and 50 feet down, and the driver got out without any issue. And we were able to drive the car in the trailer with a jack under the front end. But that year, Tim got third in class, and Rick followed him. And we're not going to try to look at this video. Okay. One of the neatest things about going to Pikes Peak is you don't get any sleep and you don't get any air. So there's nothing more fun than 5 o'clock in the morning, driving up a mountain up to about, in this case, our first practice was the top third of the mountain. So at 4 o'clock in the morning, I took a 1951 American LaFrance fire truck loaded down with 3 cars and drove it straight up a hill and parked it up there, and we practiced. I was, with the exception of the 3 drivers, I was the only member of the team that didn't get some sort of oxygen deprivation situation. We actually had a pickup going up the mountain as well, and we had to actually swap drivers. All of our drivers used oxygen, which, having seen the difference between an oxygenated driver and one that wasn't, I will never allow anybody to run that mountain without it. And Rick drove the first year without and the second year with, and he said it was like night and day. But seeing the sunrise and, up at that top of the mountain when it's 29 degrees was quite the sight. This is all tech, and for those of you who have met me before, you've probably seen this truck, which is a 1951 American LaFrance that we built it in 1996, and it has been in continual service and probably has 250,000 miles, dragging race cars around the country. It's got 150 gallons of race fuel on one side and 150 gallons of diesel on the other, and is capable of towing as well as carrying. So it's probably been the cheapest tow vehicle I've ever owned in my entire life, and remains, one of the most noticeable. More pictures. You'll notice the snow. This is roughly July 1st up there. And the first year we went, the mountain actually got closed halfway through the event for about an hour and a half, which cost us the ability to run to the top of the mountain. The second year we went again with Rick. We had a minor electrical problem that cost us one of our 2 motors, and obviously limited our power up the mountain. How many of you guys have driven Lime Rock? I got one hand in the air. Well, this is our second year, I believe, at running EVSR, and this is a lap at Lime Rock under a minute. Nope, our second year, yep. One of the more interesting things we found during the process of developing the cars is we regularly see speeds approaching 130 miles an hour at the end of the straightaway, and it's impressive. But what we found is that with proper gearing, we could drop 10 miles an hour and pick up lap times, because we were spending less time above 115, and we, with a better gear ratio, we're able to squirt the corners better, really get out of the corners, and hold our speeds. As we go up the uphill here, you'll notice we're going pretty quickly. We exceed 100 miles an hour in the no name. On a good day with everything working just right, we can sometimes see 100 miles an hour coming into West Bend. And again, we came through the downhill about 100 miles an hour, which gave us enough speed to get us this fast lap. Was a 59.75. And there still has never been an electric car to beat a minute at Lime Rock besides us. And here's a bunch of the people involved. I mentioned Dale earlier. He is the guy that makes it all happen. Christopher was our tool and inventory specialist when we went to Daytona, and that's his old Saab. It actually has the last racing Saab motor that we built. Pictured here is Andrew Smith and myself up at Alfred College, giving a chalk talk about the cars. I don't know why they're holding hands, but they're very, very close, our two lead drivers, Todd Reed, Mike Wilson. This is Mike's wife, Diane, and I having a conversation at one of the hill climbs. We've started doing more and more hill climbs. They're great venues for the car. And now that we have some additional programming available to us, we can go from about 180 wheel horsepower to about 225. That is Skip Barber and the rest of the team in our first year when we were doing some, we did a demonstration during an IMSA race. Pagoda, Giants Despair, Dale and I in the shop, and we're on grid at Summit Point in the bottom right. Back up. Oh, there's somebody. I'm not sure who that is, but he's some sort of criminal. Can you unmute yourself for a second there, Carl?
Yeah, that's clearly riffraff there. That was
It
that was
is.
at
It is
Nelson, right?
riffraff, but you know, I made him pay for the T-shirt, by the way. Carl actually, I drove with Carl's team and an associated team at the 24 Hours of Nelson Ledges last year and the previous year. And last year we brought our Gen 2 car out. No, we brought Sparky. Okay, we brought our Gen 1 car out just to get some laps at Nelson because it is one of my favorite tracks, and it's a very fast track, and that's one place where these cars really shine. And I gave Carl a chance to drive. What did you think of the car, the event?
Well, first thing I had in mind was don't bend up Charlie's car. We got to drive in the Friday practice, and kind of like what you said about Tim O'Neill earlier, it was my first time in a center seat open car on a racetrack. So it was a little odd for me to be, with my head below the door handles of the cars I was racing. But it was a riot, and boy, does it pull at high speed compared to the 318. Charlie told me to remember that I couldn't judge by engine noise how fast I was going, and to remember to brake a little earlier than I thought I ought to. And I did that just after the kink at Nelson, and it was just in time. If I had gone with my instinct, I probably would have run the car off the track. So it was amazing to me how hard it pulled. It pushed me back in the seat like a muscle car at about 100, which I thought was pretty cool. It was a lot of fun.
Cool. Well, I mean, it's first I ever heard about you almost putting it off at the kink, but you didn't, so we're all good.
No, it was after the kink. The kink was fine. It was the turn after.
Pictured here is Ed Tucker, who is also part of that same team and has a long history with BMWs, which you could probably speak to, Carl, a little more than I can.
Yeah, but he ran an E21 in ITB for a number of years with SCCA, and he's been my teammate for 11 years now in chump car racing with a E30 318. And we've done really well with that car. Had a lot of fun. We built it from a parts car, and we've managed to get a couple of firsts overall and a lot of top 5 finishes with a car that everybody assumes is too slow to do that. So been a lot of fun.
Well, Ed pictured here doing some cutting on a car because we actually lowered the motor and moved it back a little bit at one point for after one of the hill climbs because we changed from all the cars have BMW differentials except for this one, which has a quick change sprint car diff in it, so that we could do really crazy gear ratios like 9-to-1 for autocrossing or 6-to-1 for Mount Washington, 5.5-to-1 for Pikes Peak. But Ed is actually the only electrical engineer on the team and has been invaluable in the development of the program and consulting for us. As a matter of fact, he just was here a week ago preparing us for our foray into actual manufacturing, because we're in the process of building 6 new cars over the next year, and we're trying to make them identical. So we've got a new wiring harness that's being contracted by a professional harness company, which, you know, both for reliability and manageability of build and maintenance. And this is just one of my favorite videos, because this is my 0 to hero video of showing just how fast the car is relative to others. You'll see a couple of Spec E30s on the outside left and a couple of Miatas. And this is at the uphill at Lime Rock. And a couple of other angles. Closing speeds are, once you get above about 70 miles an hour, the closing speeds on anything less than about 250 horsepower is astonishing. Oh, there we go. About a year and a half, 2 years ago, you'll notice this little model. This was made by Bill Gilsow, who is a really good driver in his own right. He was our chief mechanic for Daytona in '99, but his entire life, he always wanted to pen a race car. And he made this model for us in 2015. And it took us until late 2019, with the cooperation of this gentleman, Travis Snyder, to actually build that body and get it on a car. We also felt at that time that we wanted a safer cage. We wanted to redo the chassis and make the car our own. So, you know, you'll see here our tallest driver, who's 6'3", and we're doing the sideways broomstick test. He easily passes the fore aft broomstick test, but we wanted to get the driver fully enclosed. So this is the first of our Generation 2 cars. And the subsequent chassis we have actually bring up these sidebars even higher, widen up the cage, and he fits in that car, in the new cars, just great. This is Travis working from his the drawings that Billy gave him. He did full scale vinyl silhouettes, and then basically built a buck, and then built this mold and started popping bodies out. That's Sparky, our first car. This is Ohm, our first Generation 2 car, and the 4th car we built. We now have built 5 cars and currently have 4. We lost the one at Pikes Peak. But you'll see that, you know, they're dimensionally very similar. The new car is about 100 to 150 pounds lighter than the old car. It's got a single piece body. It's a little more aerodynamic. It's much less buffeting in the cockpit. And it's, as far as we're concerned, it's a little prettier. That's our quality control inspector. And believe it or not, we have to go over and over and over, and people actually don't believe it's electric. We go to the track and demonstrate the car, and people are like, wow, it's actually fast. And we look at them and go, wow, it's actually a race car. But sometimes the obvious escapes. We are a low budget, very much, if you will, old school shop. We're very careful with the funds that are available to us. And, you know, this is, you know, for anybody that's been around a while, they've seen cars strung. We don't have a wind tunnel. We don't have access to one. But we do put a video camera on the car, watch where the strings go. And these ducts are actually for battery cooling and fire suppression should we have an incident. The one incident we did have at Watkins Glen required us to remove the body. And in the time it took us to remove the body, we did some damage. But we chose some very, very safe chemistry. So it took only 3 gallons of water to extinguish a fire. Which really is the reason we chose our chemistry. We pay a pretty severe weight penalty, probably about a 20 to 30% weight penalty. And a lot of people talk about how great Teslas are, and they are great within their design parameters. But as every one of you knows, if you've ever been on a racetrack, we're not trying to drive within our design parameters. We're trying to exceed all of the parameters. And when you do that, you know, you're going to cause problems. You're going to have risks. You're going to have incidents. These are the two new cars that we have currently. We have 6 more chassis in the shop ready to build. This was at a New Jersey event that turned out to be a monsoon. We actually had to move the cars from that area because the tires were completely submerged and the wheels and the rotors were starting to get in the water. This is our recent visit to the wiring shop, Electrosoft. And,
Charlie, I want to interrupt because Ian asked about the generator. You might want to
yes.
point that out in the previous slide.
This one over here, we call him Bubba. We have been, I won't say struggling. We, you know, when we had 1 and 2 cars, we would rent 3 or 4 power boxes at the track, and we'd have wires stretched from here to there. And once we got 3 cars, we realized we really needed to have our own power supply. And within our budgets, you know, an 85 kilowatt generator retails for somewhere between $30,000 and $60,000, and that was not in the cards. But somebody at Lime Rock took pity on us, and a fellow racer who has a really nice vintage shop up near the track, and said, you know, I got this generator in surplus. I think it has about 80 hours on it. So we dragged home a 1973 Onan, which has a 9-liter international gas motor. We've recently bought a salvage Generac diesel, and we're going to be building a whole, basically a charging truck. It's going to have close to 200 kilowatts of generation power and the ability to charge 6 cars at 75 amps apiece. So that's a big hurdle. It's a lot of power. It's a lot of energy. And it is one of the biggest challenges for expanding electric motorsport. But the truth is that we've really had very little trouble running and campaigning these cars.
Charlie,
Yes.
so you bringing up the charging makes me wonder, how long do you get? Like, how many laps can you get off of a charge on these cars compared to a gasoline car in its tank?
Our original design on these cars was to build a car that was capable of, conservatively, it was going to be capable of a competitive spec Miata time for 20 minutes. Since then, with programming and everything else, we can exceed those speeds for up to 30, 35 minutes. Our typical race time is 25 to 30 minutes, and we recently did a race at New Jersey that was 33 minutes long. Our charge times are about, they're typically about 2 hours, 2.5 hours, depending on our rate of charge. But a 30-mile, 35-mile race, no problem. We've recently done like a typical CCA track day. We can do 4 sessions that are reasonably evenly spaced throughout a day without any problem at all. And when they're 20-minute sessions, if we start with a full charge, we will probably not empty the charge out on any individual session. So as I was saying, we recently went to Electrosoft. This is their workshop. It is a minority-owned, female-owned business, and really fortunate to work with them. They're cutting us a great deal, and we're going to have basically an original equipment of quality manufactured wiring harness for what is basically a hand-built car, and we believe that is going to help us take this to another level. This was the shop about a week ago. This is chassis number 2-003, 4 and 5, 6, 7, and 8 are ready to pick up, but we don't have any place to put them. This is one of our 4 working bays. This is where we get most of the Formula car and sports racer work done. You'll notice these scissor lifts, which actually sink down into the floor, which makes working on flat bottom cars wonderful. Carl's seen the shop. It's generally not this clean, but we're now to the point where we're so busy with the EVs that we pretty much suspended all other outside work for the year to make sure that we can get to where we need to be. Our goal this year is to get 6 cars on grid at Labor Day at the Mars SCCA Regional in September.
Hey, Charlie, I just saw a question pop up in the chat box about battery chemistry and kilowatt hours.
Oh, sure. We are running lithium ferrous phosphate or LFP batteries. And as I alluded to earlier, it is vital to consider not only our own program and not only the event, program, but the future of the sport. I mean, let's face it, it's coming. We all know it's coming. We all know we're going to be seeing more and more electric cars. The last thing any of us need to see is a burnt pile of slag in the middle of the front straight. And I feel very strongly that we're running that risk if we are careless with the chemistries we choose and the construction the construction type we have. So we're running between a 27 and 29 kilowatt pack. It's rated at 27. We've taken one all the way to 29.2 as of late last year. Any more than that and the weight becomes unmanageable. We get a lot of interest and a lot of discussion about building sedans. And as I said earlier, that 2002 we're going to build is going to, with the same running gear, same batteries, same everything, is going to weigh in the mid 2000s as opposed to the high teens, which would obviously negate any possibility of getting a half an hour run at any reasonable pace. We also have a new series of videos, which we're halfway through. We've done 2 of 4. So if you search those on YouTube, you can see our discussion about battery chemistry. Somebody recently wrote an article, which I participated in, Kevin Clemens, and the discussion was very interesting because we were talking to Drag Racer, a land speed driver, and myself. And one of the things that really comes up is design parameters. When you see a Tesla running on a racetrack, which they're doing more and more, you can hack anything, but they're not hacked, and they derate. They derate very quickly. I can get a Tesla up a steep hill to derate in less than 90 seconds. If you start to try to either take that gear and put it into another car, you have to manage all your batteries, manage all the stuff. But for us, the deal breaker with the chemistry was simply the recommended fire suppression for a Tesla is 3,000 gallons of water, or just pull it to the side of the road and let it burn. Not really acceptable if you happen to be hosting a nice event with 200 other participants. In our instance, we actually had a fire at Watkins Glen. We've been testing some uprated controllers, and instead of running 3 times the expected capacity of the battery, we were running about 5 times. And about 10 minutes into a session, I noticed my right leg was getting really warm. And then I looked down and noticed that was because there were flames licking in over the side of the inside of the bodywork. So I decided to come in. I drove in, I was down in the boot, finished the lap I was on, completed it, drove into my paddock, removed the bodywork, poured 3 gallons of water over 9 cells that were engulfed, and extinguished the fire. Had that been any other lithium chemistry, it would have been beyond the capacity of conventional response at any racetrack. So it's not to say that there won't be a time and there won't be chemistry, or that the existing chemistry will be able to be managed. But at this current time, I don't feel that there really is an opportunity to responsibly run anything but lithium ferrous phosphate in the lithium family in wheel-to-wheel racing. Time trials, drag racing, all reasonable. But for an extended run where you're running full duty cycle for a whole session, I feel strongly. And generally when I question somebody hard enough, they'll say, well, yeah, maybe. And nobody wants to carry around an extra 200 or 300 pounds, but it's what you got to do if you're going to have a program that's sustainable over a long period of time. Anybody have any questions? You're really quiet.
Just like the EV race cars.
Well, you know, it is funny because Pikes Peak makes us run these 110 dB chirp sirens. Mount Washington adopted the rule. Noise is very tricky. And the sirens do not, in my opinion, work because you can't tell where they're coming from. The same way you can track, you know, it doesn't work the same way a gas car does in terms of you can hear it coming, you hear it go past, you hear it go away. In the case of the EVs, you kind of don't hear them coming, but even with the Whistler, you can't tell where it's coming from or when it's coming. They do make noise, and I think when we get a field of 6 of them whistling by, it's going to be very interesting. If you notice the one video, we had a lead in, and that was the soundtrack from us doing 140 miles an hour down the front straight at Pocono on a test day. That is the fastest we've gone. The cars are probably capable of closer to 150, but we were course limited. And truthfully, the amount of energy I'm willing to put into trying to see how fast it goes is limited when I'm more interested in developing a rental and a development program so we can see a whole series of cars out there rather than one at a time as an oddball or a novelty. It's coming. It's here. You know, we've been doing it we've got 200 finishes. As far, you know, we don't have an official DNF anywhere in our history. We've had a couple of races that were longer than, you know, we knew they were longer than our range. We entered them and we finished a lap or two before the end, but they're incredibly reliable. They're easy to drive, as Carl can attest. And really importantly, I think that, you know, just like, are you a V8 guy or are you a sports racer, are you a Formula 4 driver? It's just another race car. And that's very much to the point of how we've treated the program from the start, is there's a novelty, there's an innovation, there's a lot of engineering that went into these cars. A lot of people had a lot to do with it. But ultimately, our goal was to build a really good race car that happened to be electric. And that is the success of the program and hopefully the future of the program.
Where do you look for engines, you know, the motors? Because, you know, if you're looking for a race engine, you know where to look. But how do you delve? Like, do you go to manufacturing companies or hydroelectric power supplies?
There's actually an incredibly large availability of this stuff. You know, we've all, I mean, Don Garlitz was running a dragster trying to beat 200 miles an hour in the quarter mile. I was talking to Ed about it. He said those motors are 40 years old and made in Mexico. The technology isn't actually as new as we think it is. The application of the technology, and that's what we're good at. We took a lot of off-the-shelf parts and incorporated them into this car. We had a budget to prove concept, and that limited us on what we could do as far as purchasing power. So we bought a very well tested and you know, hundreds, if not thousands of these motors are in various, you know, mining equipment, EVs. It's all out there. Things that we had to do to make it applicable for racing were significant, but not dramatic. We don't get special wound motors. We don't have voodoo doctors building our stuff. And we're also not building 1,000 horsepower cars. But it's important to note that none of those 1,000 horsepower cars can run for more than a few minutes at a time. If you watch if any of you are familiar with the Volkswagen IDR that destroyed Pikes Peak 2 years ago. I mean, they set the overall lap record, hill record by 20 seconds. Sebastian Loeb had set it maybe 5-6 years ago with a full factory effort. Then they went and beat the Goodwood record. They turned a very fast lap at the Nürburgring. But at the ring, even if you were really paying attention, you'd realize they were 20 miles an hour slower at the end of the lap than they were at the beginning. My suspicion is that was temperature management, but they're not talking about it. And the reason they're not talking about it is because they're trying to prove an absolute performance envelope, which isn't practical except in a very specific application. And that's what we very much tried to do is we run real races with real race cars. We don't get special rules. We don't do anything that you wouldn't do when you showed up with your 2002 or your E36 when you go to a club race. When we show up on grid, we practice, we qualify. And when the green flag drops, we go. And when the checker, flies, we're hoping we're in front.
Are you using all the same engines in your cars?
Yes, we have the same motors, from
Yeah.
the beginning. We were looking at one of the challenges for us is, that very often it's like if you want good, it costs this. If you want better, it costs twice this. If you want great, it costs 10 times this. Yeah. We were very much on we have to find the minimum possible that will do the job we could do. And we knew that temperature management was going to be our biggest challenge. And actually it was an 18-year-old kid who worked for us at the time who said, "What happens if you squirt a bunch of water at the motor?" And I said, "I don't know, that sounds kind of sketchy." So we called the manufacturer, we all consulted about it, and we took a meth injection kit and took the air manifold that we use for cooling and put a nozzle pointing at the front of the motor. And every time the motor gets above 100 degrees C, we pour water on it. And we've improved our cooling and improved our mapping and management, so we don't need it very often. But it is the only thing that'll allow us to run a 25 or 30-minute session. So we'll pump about half a gallon to 3/4 of a gallon of water later in a session to manage temperature. Otherwise, we'll get thermal runaway within 10 minutes.
Okay.
Charlie, this is just such a great talk. Thank you so much. But I wanted to ask you a little bit more about the battery packs and the chemistry. You mentioned you're really sensitive to the chemistry. Could you talk more about that and how you make the battery packs and maintain temperature even in the batteries as well?
Well, again, the batteries we use, it's the Chinese aircraft lithium battery company, and it is the only battery that is actually certified by the FAA for flight. They make, at the time, they made two different battery cells. One was a very thin aluminum case battery cell that was about 1/3 the capacity of these. And these, which are very, very sturdy, thick plastic case batteries that in theory, basically, if you don't exceed their design parameters, they do not need any cooling. They could be put inside a box and run. What we discovered is that they do need cooling at the levels we run them, but most of the temperature that you can manage comes out the battery posts, out the terminals. So we ended up studding all the batteries instead of bolting them. We had copper spacers to lift the bus bars off the top of the batteries. And ultimately we ended up opening up the battery box And instead of having an enclosed box, we now have an exoskeleton that allows for passive cooling. With a battery like we use right now, there's no amount of air that you can't cool down the reaction externally in any significant way because the battery cases themselves are so well insulated. And ultimately, that's what catches fire. With an LFP fire, the actual chemistry, there's not enough free lithium in the battery to actually have an effective lithium fire. So what happens is you get enough temperature buildup to set the plastic cases on fire. They'll have what we've had in the past up until Watkins Glen was we had venting incidents where the reactions would run away inside and you'd have what smells like pears, basically. You'd have this fume coming out. And interestingly enough, that's really all that happens is you have a hot reaction that comes out of the battery at about 300, 320 degrees Fahrenheit, but does not catch fire unless it catches the cases on fire. So that's why you're able to suppress with such small amounts of water, is all you have to do is cool. You're not cooling the reaction, you're just cooling the battery case enough to keep the plastic from burning. Yes. As far as there's a lot of pieces to it. We run 50 large cells in the cars. Tesla has, anybody know, it's like, I don't know, 1,200, 1,300 little tiny batteries. Every one of those batteries is monitored, is checked for voltage, resistance, draw, and with the battery management systems required to manage a pack like that, as soon as you start reaching its capacity to either discharge or low volt or high volt, it has to derate the entire process to allow the car to continue to function, or you'll get a runaway reaction. And that's what we tried to stay away from with the cars, because if you're in first place and you're a half a lap from the end of the race, who's going to tolerate your car shutting itself off, and who is going to be responsible enough to shut it off yourself? Anybody in this room, raise your hand. Not me. I'm going to drive it till the wheels fall off, or the batteries pop out the sides, or whatever happens. So I think that it's really important to not pretend that if we give 10 guys a battery powered car and say, when the little dial gets to there, we're not going to go anymore. One of those 10 guys at least is going to go that much further, and something bad's going to happen.
Yeah, there's safety factor, right?
Yeah, well, and Eva made a really great point in this article that I referred to earlier, which is unlike liquid fueled cars, even the worst reaction is so much slower. And whether it be, a pouch pack, lithium ion, lithium ferrous phosphate, the reactions give warning. You have indication both electronically and physically. All these things happen where I have very little concern for the jeopardy of the driver as relates to the batteries, the chemistry, the fire, any of the things that are going to happen in there. If my usual explanation, because I've had to sit down with every track, every emergency crew, often the management of the track, the facilities, spoken to the insurance companies, and I say, which would you rather I do? Throw a burning battery on your floor or throw a gallon of gas and light a match? And that puts it in perspective. There's danger. There's always going to be danger. There's always going to be risk. Let's face it, that's part of what we're here for, is we're here to test the limits of things. But it is important to say, oh, I saw a Tesla blow up in a basement garage in China, and you should have seen it. Well, you should have seen the buildup of 5, 6, 8, 10 minutes of smoke pouring out from underneath it, and all the other things that happened prior to it blowing up. And as I said before, my biggest concern is not for the safety of the driver or the safety workers. My biggest concern is to disrupt an event, to damage asphalt, to create a situation or a scene where there's a burning car on the side of the road for 3 hours while you guys are going, I just paid $300 for my track time. How come this jerk gets to ruin my day? And, you know, much like letting the vintage cars run before us and they oil the track. But it's being part of the community. It's being responsible to the community. And as an event organizer, as a track manager, I get all that. I understand how important it is to have a guy pull off in a safe place and not black flag a session, to have the fire happen where somebody can extinguish it, you know, and all those things. You know, it's not just the individual involved in the incident that's affected.
Thank you.
Anybody else? So who wants to drive one? Raise your hand.
Oh, yeah.
Okay, well, here's what I'll tell you. As of this year, we have a rental program. By the end of the year, we will have a half a dozen cars. If any of you, event organizers, any of you people who are familiar, you know, friends with, I can bring cars. I can go to events. I would, you know, I welcome people into the cars. You know, we've had Andy Lally drove a car at the IMSA demo. We've, you know, we did an autocross where we were handing out rides like popcorn. We ended up getting 1st, 2nd, 6th, 9th, 12th, and 21st at that event because everybody said, wait a minute, he just drove it and it went fast. I want to drive it. They're great cars to drive. We want to share them. We want people to get the word out. We want people to experience them and to understand that it's, you know, in one sense, it's just another race car. And the truth of it is, it's a really good race car and it deserves to be experienced by more than just a couple of people. So don't hesitate to reach out to us and find out how the rental program works, find out if there's an opportunity. You know, if you guys got 50 people together and said, we'll all cough up $50 and we'll give you, you know, we'll get some track time in between or during the sessions and everybody's a certified driver and we'll take the cars there. Anywhere that we can get these things shown, seen, and enjoyed, we're all in.
Cool.
I can definitely say that having had a chance to drive it a little bit, both at Pineview here near Syracuse and at Nelson, the car is a lot of fun. And one of the things that a bunch of people said at Pineview was they didn't expect it to be fun. They got in the car and they said, wow, this thing is neat to drive. There were a lot of people who were being internal combustion snobs when they started. And at the end of the day, they were saying, this is kind of neat. So one ride in it will convert you from a skeptic if that's your point of view.
We have a whole library of post-drive reviews from drivers on the YouTube channel as well. So,
well, one of the things, how many of you guys have driven an electric car? It's interesting because most people who have driven an electric car have experienced a Tesla somewhere because there's more of them. But the neat part is when you start taking the Econo boxes, the Leafs and the Hyundais, those are the cars that really shine because all of the disadvantages of a small car are mitigated. The vibration, the cheap running gear, all those things that make a small, inexpensive car less desirable to a lot of people are mitigated by an electric drive. And for example, in the rain, putting down power with one of these cars is like no other. And I've driven GT1 cars, Formula Fords, winged cars, 100 different sedans, if not more, front drive, rear drive, pushers, pullers. I've never driven a car that was that easy to just squeeze in the power, release the power, adjust in the middle of a corner. And, you know, there's so many things that you'll never experience until you try it. And as Carl said, it's easy to say, I'm not interested. Take a chance, you know, try something new because it's really, my first lap out was faster than I'd ever driven a sports Renault. And we had just taken the car out. I took it out around Summit Point, and my outlap from pit lane was faster than I'd ever gone in a Renault. We're under a minute at Lime Rock. We have an average lap of over 100 miles an hour on the short course at Watkins Glen. For those of you who've been to Summit Point, I just turned to low 25 there last fall. They're quick and they're good to drive.
Charlie,
Yes.
there were two questions in chat from the students. They were asking, I'll just paraphrase, is there any design consideration for the chassis that you have to think about that's different for an electric car versus a gas car? And then secondly, what kind of battery management system are you using?
Because of the batteries that we use, we do not use a battery management system. We have very careful and close monitoring of voltages, and we have a minimum voltage cutoff. We have some temperature cutoffs that put it not into limp mode, but into reduced power mode. So again, that comes back to the battery chemistry choice and the specific battery we chose to eliminate the 150 wires that it would require to add that to the harness, which is weight, complication, and again, reliability. And the first question again, could you repeat it?
I think the
chassis considerations.
Yeah.
Chassis considerations were very interesting because I've built many race cars, and the car in this picture, Sparky, was from before it had wheels, it was on the scales. And once it had wheels on it, it lived on the scales. Everything we did, we built on the scales. And the joy of building an electric car is that unlike, you're going to build a 2002 or you're going to build a NASCAR, and they have rules as to where you can put the motor, because if you put it 4 inches further back, it makes a huge difference. Well, I can shovel 50 pounds anywhere I want in that car and not change anything. I mean, I just move batteries from 6 inches further back, and I've changed the dynamic weight balance of the car tremendously. So I guess realistically, there weren't a lot of challenges to it, but there was a lot of flex in terms of the setup, but there was so much flexibility that I could design the car around my desired goals instead of being constrained by the chassis or the design, or I've got a really heavy motor that I'm stuck with, or the gas tank has to be there and it's gonna, and things like that. The car doesn't change weight during a session. So the biggest thing was moving the driver around to get him in the right place, keeping the weights where we wanted it. And because the batteries are, we're talking about 325 pounds a piece on either side of the car, we had to make sure that we had safe containment and, crash worthiness as relates to the batteries. That was one of the big considerations. And then because we run a relatively long longitudinal motor, we wanted to make sure that we had a little bit of crash worthiness at the back of the car to absorb, an initial impact there. But really, it wasn't, as far as building a race car from scratch goes, this was easier than any gas car I'll ever have to build.
Very cool. Well, do we have any other questions? Because if not, I think I'd like to, maybe we could all thank Charlie. It's tough,
Yes,
half are
thank you.
muted, but you could unmute to at least give him a little applause.
Thank you. Thank you very much. Very
Thank
interesting.
you.
Well,
Thank you.
keep in touch, subscribe to our YouTube. But if you're really interested, this is not some elitist program that you have to bring a sponsor and I'll be candid, our rental rate is $1,500 a day. Yeah, you got to pay for crash damage and abuse, but that's just like any other rental. But the point of this program is to make it accessible. For 10 cents on the dollar, Formula E has, now has a little more performance. For the first 3 years, we were running longer range and much higher, like 10 mile an hour higher average laps. And our goal is to make this available to anybody. You know, with the concept that you can spend $100,000 to build a competitive E46, I'm right in that park, you know, so it's doable. And most importantly, we do want to share this with everybody and as many people as we can. So if you or anybody you know is interested, let us know. And if you know any electricians that want to help us out with some pretty complicated work on our generators and transformers, we'd love to have you put us in touch with that.
I think we have a couple students that might be interested.
Awesome.
I'm all in.
All right. Well, thank you, everyone. I think let's conclude the meeting. And thank you again, Charlie. That was awesome.
Great, thank you.
I'm going to stop recording. And if you could stop screen sharing.
You have to